Hello, hello, and welcome to this video of Python exemplified read-throughs. So we were going through the bisect module. In the last video, we completed it. In this video, we will go through array. So in general, people make use of list, but there are times when arrays are better than lists. Arrays are efficient arrays of numeric values. So unless you want to use NumPy, which has very efficient ND-array module, arrays will help you do the similar thing. Not as good as NumPy, but quite efficient. Okay. So in Python, if you don't want to use NumPy, but you want something which can give you this facility, you can use the array module. Now, like C, C++, Java, these are homogeneous type, unlike the heterogeneous list module. The main reason for list to be inefficient is that it is heterogeneous. It has to accommodate all kinds of types. But arrays have restriction that they are of the one type, that is, they are homogeneous. So it is possible to implement them efficiently. So let's go through the documentation and then we will look at the example. This module defines an object type which can compactly represent an array of basic values, characters, integers, floating point numbers. Arrays are mutable sequence types and behave very much like lists, except that the type of object stored in them is constrained. The type is specified at object creation time by using a type code, which is a single character. The following type codes are defined. So we have B, that is for bytes, signed char, integer, maximum minimum size in bytes is 1, capital B on signed char, int, maximum minimum size 1, U is WKRT, Unicode character 2 bytes, W is 5UCS4, Unicode character 4 bytes, H for signed short, integer 2 bytes, capital S is unsigned short, integer 2 bytes, I is signed in, which is of type integer, 2 bytes, capital I is unsigned in 2 bytes, L is signed long, which is of integer type, 4 bytes, capital L is unsigned long, integer 4 bytes, Q is signed long, integer 8 bytes, capital Q is unsigned long, integer 8 bytes, F and D are float and double, and they are 4 and 8 bytes in size. Now we have notes for 1 and 2, that is Unicode characters. It can be 16 bits or 32 bits depending on the platform. Now, see also the C types and struct modules, as well as third-party modules like NumPy use similar but slightly different type codes. The actual representation of values is determined by the machine architecture, strictly speaking, by the C implementation. The actual size can be accessed through array.itemSize attribute. The module defines the following item, array.typecodes, a string with all available type codes. The class defines the following types. So we have the constructor, which takes the type code and an initializer. A new array whose items are restricted by type code and initialized from the optional initializer value, which must be a bytes or byte array object, a Unicode string, or table over elements of the appropriate type. If given a bytes or byte array object, the initializer is passed to the new arrays from bytes methods. If given a Unicode string, the initializer is passed to the sum Unicode method. Otherwise, the initializer iterator is passed to the extend method to add initial items to the array. Array objects support the ordinary mutable sequence operations of indexing, slicing, concatenation, and multiplication. When using slice assignment, the assigned value must be an array object with the same type code. In all other cases, type error is raised. Array objects also implement the buffer interface and may be used wherever bytes-like objects are supported. Arrays are generic over the type of their contents. Arrays is an auditing event, array dot underscore new underscore with arguments, type code, comma initializer. Now type code is the type code that you to create the array. Item size is the length of bytes of one array item, and then internal representation. We have append where we give a value argument. Append a new item with the specified value to the end of the array. Buffer info return a tuple address comma length giving the correct current memory address and the length and elements of the buffer used to hold arrays contents. The size of the memory buffer in bytes can be computed as array.bufferinfo and then 1, which is the length, multiplied by array.item size. This is occasionally useful when working with low-level and inherently unsafe I/O interfaces that require memory addresses such as certain IOCTL operations. The return numbers are valid as long as the array exists and no length changing operations are applied to it. When using array objects from code written to C and C++, the only way to effectively make use of this information, it makes more sense to use the buffer interface supported by array objects. This method is maintained for backward compatibility and should be avoided in new code. The buffer interface is documented in buffer protocol. Then we have byte swap. Byte swap all items of the array. This is only supported for values which are 1, 2, 4, or 8 bytes in size. For other types of values, runtime error is rate. It is useful when reading data from a file written on a machine with a different byte order. Then we have count, return the number of occurrences of value in the array. Extend takes init table, appends items from a table to the end of the array. If a table is another array, it must have exactly the same type code. If not, type error will be raised. If a table is not an array, it must be a table and its element must be the right type to be appended to the array. Then we have from bytes, appends item from the bytes like object, interpreting its content as an array of machine values as if it had been read from a file using from file method. From file takes f and n, read n items from the file object f and append them to the end of the array. If less than n items are available, UF error is read, but the items that were available are still inserted into the array. From list takes a list argument, append items from the list. This is equivalent to for x in list a.append x, except that if there is a type error, the array is unchanged. From Unicode takes a Unicode string, extends this array with data from the given Unicode string. The array must have the type U or W, otherwise the value error is read. Use array.from bytes Unicode string.encode encoding to append Unicode data to an array of some other type. Then we have index, which takes a value and stop optional arguments, return the smallest I such that I is the index of the first occurrence of the value in the array. The optional arguments start and stop can be specified to search the value within a subsection of the array. Raise value error if value is not found. Insert takes an index and a value. Insert a new item value in the array before position index. Negative values are treated as being relative to the end of array. Then we have pop. Index is equal to -1, removes the item with the index I from the array and returns it. The optional argument defaults to -1 so that by default the last item is removed and returned. Then we have remove, which takes a value argument. Remove the first occurrence of the value from the array. Then we have clear, removes all elements from the array. Reverse reverses the order of items in the array. 2 bytes convert the array to an array of machine values and return the bytes representation. The same sequence of bytes that would be returned to a file by the toFile method. Then we have toFile method, which takes a file handle, write all items as machine values to the file object f. ToList convert the array to an ordinary list with the same items. ToUnicode convert the array to a Unicode string. The array must have a type U or W, otherwise the value error is read. Use array.toBytes.decode encoding to obtain a Unicode string from an array of some other type. The string representation of array objects has the form array typecode comma initializer. The initializer is omitted if the array is empty, otherwise it is a Unicode string if the typecode is U or W, otherwise it is a list of numbers. The string representation is guaranteed to be able to be converted back to an array with the same type and value using eval, so long as the array class has been imported from using from array import array. Variable inf and nan must also be defined if it contains corresponding floating point values. So we have example of array creation. We have L, so it is an empty array. Then we have W, which is Unicode, hello, and a Unicode character. L is for signed long, 1, 2, 3, 4, 5, and D is for floating double, so that is 1, 2, 3.14 minus infinity and none. So that's all the documentation we have about our array. Very simple module, nothing complicated. And now we'll look at the example. So from array we import array and import OS, and we print 17 is equal to creating arrays. So you see it is I, that means it will be signed integer, and we have D, that is double, so we create numbers and floats. Then we print the type code of numbers, and item size we print in bytes of numbers. And then we have append to numbers, we append 60, so it will be at the last position. Then we have extend numbers, we extend by 70, 80, 90, and then we insert at position to 999, and we remove 999 from the array. Then we get the last element of numbers and we remove the last element of numbers. Then we call reverse on the numbers, and then we get the buffer info, and we have the memory address and length, and then we have the count number. We append a number and we print numbers. Then we print count and index of 20. Then we slice. So slicing example you already know. This will give the first three values 0, 1, 2, and this will give us -3 onwards, and this will give every second numbers. Then we have slice assignment. So to the array I, we give it 2 elements, and this array we put in the sliced derivative of the numbers, and then we print numbers, and you can treat all the numbers as value in numbers. Then we have from list. We create an array from this list of type integers, and then we have toList. Then we print the list and we see the type of list, and then we have 2 bytes. We print it 2 bytes and length of bytes. Then we have from bytes. From bytes we get what we created D. From that we create the array, which is a copy. Now we do file IO. We create a file named numbers.bin, and we put the numbers in that file, and we read that, and we load from file and put that in loader. So it should be the same, and then we remove the file. Then we have copy example. We have a copy 2. Now note that array A is a.typecode, comma A. So we append 100. Original is that, and copy is there. And then we multiply. So we multiply the array, and we print it after multiplication. Then we do concatenation. A plus array 678. Membership is text is here, 3 in A or 99 in A. Then we have aggregate functions, min, max, sum, length. Then we can sort this. So this is an unsorted array, and then we can call sorted on this with type I, and we have the sorted array. Okay. Then we have equality tests. So two arrays are being compared for equality. X is equal to Y will be true, and X is equal to Z will be false. Then we have memory comparison. So we have a list from range 1000, and we have an array from range 1000, and we look at the list size, we look at the array size, and then we have common type codes. So these are the common type codes, and for that we print the type code and description. So if you want to run this, I can show you. So this would be Python 3 space arrays.py, and there we go. So as you can see, list size is quite large compared to array size, even though same number of elements are there, and you can verify the output at your leisure. Okay. So file IO loaded is the same. 2 bytes is, this is how hexadecimal bytes look like. And it's essentially very simple. So I'm not going to give the details of the output. I'll put this code as a gist, and we can take this file from there and play to your heart's content. So with this, we come to the end of this video, and I hope that you have enjoyed this video and learned something about the array module of Python. So thanks a lot for watching the video. We will meet again after 4 days. with another video on Python. Till then, I will take my leave. You have a great day. Stay curious, keep learning, and most importantly, enjoy.